All right, today we're going to be looking at particle motion, which is position, velocity, and acceleration. And it's always talking about a particle moving along the x-axis. So it's either moving left or right. What you're given is always the velocity function. There's a velocity function and an initial position, some sort of initial condition. It doesn't have to be at time equals 0, but they'll give you a position. And then the questions are pretty consistent. The first type of questions they can ask you are questions directly about the velocity. So what are some things they can ask? Well, they can ask when the particle is stopped or changing directions. And for those questions, we want to look at the velocity directly, because the velocity being 0 tells you when the particle is stopped. And at 0, it will change directions, although it could change directions if it's undefined as well. So that's what we're looking for. And let's look at the last 3 years and see where this has come up. In 2016, we wanted to find all times where the particle changes direction. So that's just taking the velocity and setting it equal to 0 and solving the equation that makes the velocity equal to 0. Notice we're not putting in time equals 0. We're setting the velocity equal to 0 to find where the particle is stopped or changing directions. It also came up in 2017 in part D as part of the question. It said find the position of the particle, and we'll come back to this in a second, the first time it changes directions. And so we're looking for where the velocity was equal to 0 first, and that's where it'll change directions. And we'll come back to that in a second. So that's a velocity question. Another velocity thing they could ask about is which direction. So is it moving left or right along the x-axis? They could also say what direction it's going. And the direction is directly related to the velocity. Remember, the velocity is how a particle is moving. And so v of t is positive, means the particle is moving to the right. V of t is negative, tells you the particle is moving to the left. And this came up in 2017, both in A and B. When is the particle moving to the left? And so we needed to find where it was 0 and make a sign chart. So we're looking for the velocity. We set it equal to 0, and we make a sign chart. And then we're finding where the particles are traveling in the same direction. So we wanted to find where the particles are traveling left and right by using a sign chart. And there were 2 different particles. Now this one, it only gave you the position. And so of course you need to know that the velocity is the derivative of position. And so we would need to use the 2 velocities to compare each other. Another thing they could ask you is the speed. This comes directly from the velocity. Speed is how fast, velocity is how fast and in what direction, and so the speed is the absolute value of velocity. So if you take the absolute value of the velocity, that just gives you the speed. It hasn't come up recently, but it's come up before. All right, other common questions they ask are about the position. The first thing is they often ask about the position at a certain time. So position at time equals A, we'll say it, okay? And remember, they will give you an initial position, and we'll call that initial position B. So at, there's initial position, and so we'll say at, I guess we should say at T equals B, the position is C. And if they want to know the position at time equals A, then the way we find it is the fundamental theorem of calculus. The fundamental theorem of calculus says that if we know the initial position, which was C, then we can add in the displacement, or how much the particle changed by, between t equals b and t equals a. So this is the starting time that they gave us the initial position. And if we take the integral of velocity, that will give us the displacement. This comes up very often. It comes up every year pretty much. It came up in 2016 in part D. Sorry, well, I'm in the wrong thing. It came up in 2016 in part C. Find the position at time equals 0. So we would take the initial position and add in the integral from 4 to 0 of v of t. And this could just go straight in a calculator, and it'll give us the answer. It came up in 2017 in part D. It said find the position of the particle when it changes direction. So it's going to be the initial position plus the integral from, it started at time equals 0. And you needed to solve for this. I believe, just doing it in my head real quick, it looks like it is 3. The integral from 0 to 3 of VQ of t. And it just straight up gives you the position. It's the starting position plus how much the displacement was. This came up again in 2018, so pretty much every year. In part B, it said find the position of the particle at time equals 3. So you'll notice this one came up every time, and so the position is the initial position plus the integral from where the time it started until the time it's asking about of the velocity. Great. A couple other position questions they could ask us. The displacement, which means how much did the position change by from the beginning to the end. And this is just the integral from the beginning to the end of v of t. A related concept to displacement isn't just how much did it end up, where did it end compared to where it started, but total distance. Total distance is similar, except we don't care if it went forwards and backwards and then forwards again. Displacement is just this position minus this position, whereas total distance measures this whole path it took. And this is the integral of the absolute value of velocity. This is the total distance something traveled, because remember, this is the speed. And if we just add up how long it went times the speed, that will give us the total distance traveled. The last question they could ask about are acceleration. So things about acceleration. And for this, you need to remember that the derivative of velocity is acceleration. And you need to write this if they ask for the acceleration. You need to say v prime of something. This came up in 2018. It just straight up asked, what is the acceleration at time equals 3? And it's completely fine to just type into your calculator, find the derivative of the function at time equals 3, like you plug in the function and put it into your calculator, it's fine. But what you had to write down was v prime of 3 equals, and then give your answer that you get from your calculator. Some other acceleration questions they could ask are, is the velocity increasing or decreasing? Remember that acceleration is the derivative of velocity, so if the acceleration is positive, the velocity is increasing. If the acceleration is negative, the velocity is decreasing. That hasn't come up recently. A very common question is the speed increasing or decreasing? And in order for the speed to be increasing, we don't actually care whether the acceleration is positive or negative. We care whether it's going in the same direction as the velocity. So for the speed increasing or decreasing, you need both the velocity and the acceleration. If they are the same sign, the speed will be increasing. If they are the opposite sign, the speed will be decreasing. And this should make sense. If the velocity is positive, but the acceleration is negative, the new velocity will be a little bit smaller and the speed got smaller. If the velocity was positive and the acceleration is positive, the new speed is bigger. If the velocity was negative and the acceleration is positive, well, that means the velocity increased, and so it became a smaller negative. The speed got smaller. And if the velocity was negative and the acceleration was negative, the velocity is now even more negative, and so the speed got bigger. So we need to compare the velocity with the acceleration, and if they have the same sign, the speed will increase. If they have the opposite sign, the speed will decrease. This comes up pretty frequently. It came up in 2016 in part A. At time equals 4 is the particle speeding up or slowing down. So v of 4 we find to be some number just using a calculator. A of 4 is obviously the derivative at 4, and again you would just use your calculator to get that. And then to see if it's speeding up or slowing down, we would need to see are these both positive, both negative, or opposite signs. If they're both positive or both negative, the particle is speeding up. This also came up in 2017 in part C. It asked you to find the acceleration. So acceleration at 2 is the derivative of the velocity at 2, and that comes up to be some number. This is how your labeling should look. And then we can tell the speed by comparing the acceleration at 2 and the velocity at 2 and seeing are they the same sign or opposite signs. All right, that about covers the common position velocity questions. Hopefully that's helpful.